Question number 66. Construct a minimal DFA that accept language over alphabet sigma equal to a comma b, where each string contain number of A's and number of B's divisible by 3. Please try to do this question. This question can be written as number of A's in a W congruent 0 mod 3 and number of B's in a string congruent 0 mod 3. There are other possibilities are also. First, you can design for this. After that, we will see some modification in this question. Try to do this question. Do fast. First you design for the number of A's divisible by 3 and second DFA for number of B's divisible by 3. After that compound these two DFAs. Number of A's divisible by 3, Q0, Q1, Q2. Number of A's divisible by 3. Number of B's divisible by 3, Q3, B, Q4, B, Q5. This is number of B's divisible by 3. Okay. Now, how many number of states are present when we design a DFA for number of A's and number of B's divisible by 3? Cross product. Q0, Q3, Q0, Q4, Q0, Q5, Q1, Q3, Q1, Q4, Q1, Q5, Q2, Q3, Q2, Q4, Q2, Q5. These are the number of states present in this DFA. How many number of states? 1, 2, 3, 4, 5, 6, 7, 8, 9. Which one is initial? This one is initial. Which one is final? Q0, Q3. This is final for this question. Now, make the DFA for this. How many number of states? 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the Q0, Q3. This is Q0, Q3. This is initial and final. What are the transition on Q0, Q3, Q0 on A, Q1, Q3 on A, Q3. So this one is Q1, Q3 on A. Okay. On B, Q0, Q4. Q0, Q4. This is Q0, Q4. Q0, Q4. Q0 on B, Q0, Q3 on B, Q4. Clear? This is B. Now for Q1, Q3. Q1 on A, Q2, Q3 on A, Q3, Q1 on A, Q2, Q3 on A, Q3. Now Q1 3 on A, Q2, Q3. This is Q2, Q3. Okay. Now for B, Q1 on B, Q1 on B, Q1, Q3 on B, Q4, Q3 on B, Q4, Q13 on B, Q1, Q4, Q1, Q4. This is the Q1, Q4. Okay. Now check for this Q0, Q4. Shall I remove this? For Q0, Q4. Q0 on A, Q1, Q4 on A, Q4, Q0 on 4, Q0, Q4 on A, Q1, Q4. This is Q1, Q4. What about B? What about B? Q0 on B, Q0, Q4 on B, Q4 on B, Q5, Q04 on B, Q0, Q5, Q0, Q5. This is Q0, Q5. Okay? Clear? Now, check for this one, Q1, Q4, Q1, Q4, Q1, Q4, Q1 on 0, sorry, Q1 on A, Q1 on A, Q2, Q4 on A, Q4. Then Q1, Q4 on A, Q2, Q4, Q2, Q4. This is Q2, Q4. What about B? What about B? Q1 on B, Q1, Q4 on B, Q4 on B, Q5, Q1 4 on B, Q1 5, Q1 5, Q1, Q5. This is B. Clear? Now check for Q0, Q5, Q0, Q5, Q0, Q5, Q0 on A, Q1, Q5 on A, Q5. It means Q0, Q5 on A, Q15, Q15, Q15. Clear? What about B? Q0 on B, Q0, Q5 on B, Q3, then Q0, Q5 on B, Q03, Q03, Q03. This is B. Okay. Now check for Q15, 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 Q1 on A, Q2, Q5 on A, Q5, Q25, Q25, this is Q25, Q25, clear? Now for B, Q1 on B, Q1, Q5 on B, Q3. It means Q1, Q5 on B, Q13, Q13, Q13. This is the B. Okay. Now check for next state Q25. Q2, Q5. Q2 on A, Q2 on A, Q0. Q5 on A, Q5. It means Q2, Q5 on A, Q0, Q5, Q0, Q5, Q0, Q5. Where is Q0, Q5? This is the Q0, Q5. For B, Q2, Q5. Q2 on B, Q2, Q5 on B, Q3. It means the transition of B on Q2, Q5 is Q2, Q3. Is Q2, Q3. Clear? Next, Q2, Q4. Find the transitions A on A or B on Q2, Q4. Q2 on A, Q2 on A, Q0. Q4 on A, Q4. It means Q2, Q4 on A is Q04, Q04, this one. Okay. Next, Q2 on B, Q2, Q4 on B, Q5. It means Q2, Q4 on B, Q2, Q5, Q2, Q5. This is the B. Are you getting my point? Are you getting my point? Okay. Next state is Q2, Q3. Q2, Q3. Q2, Q3. This one. Find out the transition on B and A. Q2 on A, Q3 on A. Q2 on A, Q0. Q3 on A, Q3. Q2, Q3 on A, Q0, Q3. This one. Q2, Q3 on B. On B. Q2 on B, Q2, Q3 on B, Q4. Q2, Q3 on B, Q2, Q4, Q2, Q4. This is the DFA for this. Now check. Epsilon is accepted. Triple A, triple B is also accepted. AB, AB, AB is also accepted. Number of A's and number of B's are divisible by 3. Now check for first string. A, B, B, B. Accepted. Next AB. A, B, A, B, A, B. Accepted. Now check. Check this question, please. Clear? Are you getting my point? Okay. Change the question. Check. If the can we modify this? Yes, we can modify this. Which one is final state? Which one is final state? In this diagram, this one is final. It means Q1 and Q3 is final. Q1 and Q3 is final. Q1 and Q3 is final. Q1 and Q3 is final for this question. Number of A is divisible by 3, then remainder should be 1, and number of B is divisible by 3, remainder is 0. It means this accept this language. A, simple A, single A is also accepted. A triple B is accepted. A, B, B, B is accepted. Clear? Check. Okay. Now, this question can be asked as, suppose many combinations. This is also can be asked. 1, 2. It means this one is final. Q1 and Q1 Q5 is final. Q1 and Q5 is final. Q1 Q5 this sorry, Q1 Q5 is final. This can be final. Okay. Another way to ask this type of question, number of A's in a W mod 3 greater than number of B's in a W mod 3. This type of question can be asked. Clear? Many more combinations are possible. Clear? Shall we move on next question? This is the 66th question. Check. Okay. Shall we move on next question? Question number 67. Construct minimal DFA for the regular language L equal to W such that decimal value of binary number W is divisible by 2 or 3. Try to do this question. Try to do this question. Have you done? No? Okay. Check. Binary number, decimal value of binary number W is divisible by 2 or 3. First we find the divisible by 2. Remember the shortcut 0, 1. How many number of remainders are possible? 2. Then number of state Q0, Q1. This is the initial and this one is final. Q0, Q1, Q0, Q1. What is the DFA? This is Q0. This is Q1. Q1 on 0, Q0. Q1 on 1, Q1. Check. This is the correct DFA or not. What is the number of decimal this? 2. When we divide 2 by 2, the remainder is 0, 1, 0. Clear? Now, divisible by 3. How many number of remainders are possible? 3, 0, 1, 2. Then number of states? 3. Q0, Q1, Q2. This is initial and final. Q0, Q1, Q2. Q0, Q1 and Q2. Are you remembered the shortcut? Yes, very good. What is the DFA for this? Remainder 0, Q2. Remainder 1, Q3. Remainder 2, Q4. Q2, sorry, this name is different. Q2, Q3, Q4. 3 states. Q2, because Q0 and Q1 already used. Q2, Q3, Q4, Q2, Q3, Q4. Okay. Q2 on 0, Q2. Q2 on 1, Q3. Q3 on 0, Q4. Q3 on 1, Q2. Q4 on 0, Q3. Q4 on 1, Q4. This is 1. Clear? Yes or no? Clear? Very good. How many number of states? 6. For this Q0, Q2, Q0, Q3, Q0, Q4. Q1, Q2, Q1, Q3, Q1, Q4. These are the states for the final DFA. 6 states. These are the 6 states. 1, 2, 3, 4, 5, 6. This is the initial state. Which one is initial? Q0, Q2. Also this is final. No. Or. There we use or. It means which one is final? This is final. Q0 is final. This one is final. This one is final. These 4 states are final. These 4 states are final. Clear? Now, find out the transitions. Shall I remove this? First, Q0, Q2 on 0, Q0 on 0, Q0, Q2 on 0, Q2. Then Q0, Q2 on 0, Q0, Q2, self loop. Clear? Clear? Now find for 1. Q0 on 1, Q0 on 1, Q1, Q2 on 1, Q2 on 1, Q3, Q0, Q2 on 1, Q1, Q3, Q1, Q3, Q1, Q3. Where is Q1, Q3? Suppose this one is the Q1, Q3. This for 1. Clear? Now check for Q1, Q3. Q1, Q3 on 1. Q0 on 1, Q1, Q2 on 1, Q3. Now check for Q1, Q3. Q1 on 0, Q0, Q3 on 0, Q3 on 0, Q4. It means Q1, Q3 on 0, Q0, Q4, Q0, Q4. Suppose this is the Q0, Q4 on 0. Okay. What about 1? Q1 on 1, Q1 on 1, Q1, Q3 on 1, Q3 on 1, Q2, Q2, Q13 on 1, Q12, Q12. Suppose this one is Q12. Okay. This is the one. Clear? Now check for Q1, Q2. Q1, Q2. Q1, Q2. Q1 on 0, Q0, Q2 on 0, Q2, Q2. It means Q1, Q2 on 0, Q02, Q02. This is for 0. For 1, Q1 on 1, Q1, Q2 on 1, Q2 on 1, Q3. It means Q1, Q2 on 1, Q13, Q13, Q13. This is for 1. Okay. Next state Q0, Q4. Find out the transitions. Find out the transitions. Do fast. Q0 or Q4. Q0, Q4. Q0 on 0, Q0, Q4 on 0, Q3, Q0, Q4 on 0, on 0, on 0, Q0, Q3, Q0, Q3. We don't have Q0, Q3. This is Q0, Q3. Q0, Q4 on 0, Q0, Q3. Okay. For 1, Q0 on 1, Q1, Q4 on 1, Q4 itself. It means Q0, Q4 on 1, Q14, Q14. We don't have Q14. This is the Q14. Now, we complete this state, this state, this state and this state. Now Q0, Q3. Q0, Q3. Check for Q0, Q3. Q0, Q3. Q0, Q3. Q0 on 0, Q0, Q3 on 0, Q4. Q0, Q3 on 0, Q04. Q04. Where is Q04? This is the Q04. For 1, Q0 on 1, Q1. Q3 on 1, Q3 on 1, Q2. It means Q03 on 1, Q12, Q12. Where is Q12? This is the Q12. This is for 1. Clear? Next is Q14. देखिए, see, this state have two transition 0, 1. This state have two transition 0 or 1. This state have two transition. This is 0 for this is 1. This state have two transition 0 and 1. This have 0 for this 1. But Q14 remaining. Q14 is remaining. Now find out the transitions for Q14. 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 Q1 on 0, Q0, Q4 on 0, Q4 on 0, Q3, Q14 on 0, 03, 03. Where is 03? 03. This is the 03. This is 0. For 1, find out the transition for 1. Q1 on 1, Q1 on 1, Q1. Q4 on 1, Q4. Q1 on 1, Q1. Q4 on 1, Q4 itself. Then Q14 on 1, self loop, self loop. This is the final DFA for this. No. What are the final states? Q02, this one is final. In case of OR. Q03, this is final. Q04, this is final. Q12, Q12, where is Q12? This is final. 4 states are final. 4 states are final. Please check this. Check. 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 Clear? Okay. Change the question. Instead of OR, we use AND. We use AND. Instead of OR, we use AND. We use AND. Then what are the changes in DFA? Only number of final states. Only number of final states. Only number of final states. In case of AND, only Q0, Q2 is final state. Q0, Q2 is final state. This one is final. Clear? And many more modifications are possible. This one is final. This one is final. Clear? Any doubt? Okay. Shall we move on next question? Yes. See the short trick of this type of questions, please. 67, 68. Suppose we have given big question, then what kind of questions asked in GATE? Only number of states. Maximum questions are for number of states. How can we find out? Question number 68. Construct, sorry, find the minimum number of, find the number of states in minimal DFA that accept all strings of A's and B's, all string of A's and B's, where each string contain number of A's in W is divisible by 4 or 3, and number of B's in a W divisible by 5. Then how many number of states? 15. Cross product. For this we have 3 states, for this we have 5 states. Then final how many states we can get? 15. Check. Number of A's Q0, Q1, Q2. This is final. This number of A's divisible by 3. Okay. Number of B's divisible by 5. A, B, C. This is final. 1B, 2B, 3B, 4B, 5B. A's, A. Clear? Then how many number of states are possible in this DFA? Q0, 1, Q0 A, Q0 B, Q0 C, Q0 D, Q0 E. This is initial and this one is final. Q1 A, Q2 B, Q3 B, C, Q4, sorry. Q1 A, Q1 B, Q1 C, Q1 D, Q1 E, Q2 A, Q2 B, Q2 C, Q3, Q2 D, Q2 E. These are 15 states. Which one is initial and which one is final? Q0A is initial and this is also a final state for this question. Now, another question. How many, find out the number of final states, in minimal DFA that accept all string of A's and B's where each string contain number of A's congruent 0 mod 3 or number of B's congruent 0 mod 5. Then how many number of states are final? This case, total number of final states in case of or this is final, this is final, this is final, this is final. Clear? Clear? And where is A is present? This one is final, this one is final. Total number of final states 7, I think. 5, 6, 7. This type of question also asked in gate questions. Clear?